Welcome. This is the second part of our implementation of a crowdsourcing blockchain application. Now, last time we defined what exactly a crowdsourcing campaign is. Here, and we defined some helper functions to help us calculate, whether we can collect from whether the owner can collect from the campaign, or whether a contributor can get a refund, and also how much money is actually in the campaign. Now, in this video, we're going to implement the validator script for our application. Now, quoting from the Plutus book, there are two scenarios where people want to claim funds from the script. The first is when the campaign owner is collecting after a successful campaign, and the second is when contributors are demanding a refund after the campaign has failed. For the validator script to decide whether such a claim is valid, it has to know which of the two scenarios applies, which tells us that the redeemer scripts must contain this information. So, therefore, we will use the following type for our redeemer scripts. Data campaign action is either collect or refund. Okay. Make left campaign action. Okay. Now, contributors can give funds to the campaign until the end date. To decide about a refund claim, we have to know that the deadline has passed and whether the contribution reclaimed has indeed originally been made by the person claiming the refund. So we need information on where the contribution is coming from attached to each script output. Now, we could use the public key, the type public key for this, and just because let's say, it just values a public key, and that's how you know who has contributed. But in order to avoid confusion, the previous book recommends that we use a new type. So we would define the following: new type contributor equals contributor get contributor public key. Okay, so basically we're just wrapping the we're still using the public key, but we're wrapping it in the type contributor, so we know the difference between when we have a public key, a vanilla public key, versus when we have a public key that represents somebody who has contributed to the fund. And then we just add to this, make a lift contributor. Okay, great. Alright, now we can embark on writing our validator script. So we first define the type. We got type campaign validator. Campaign validator equals contributor campaign action pending transaction to bool. So our validator is a function that takes a contributor. This is for the data script. The campaign action for the redeemer script. The transaction to be, it's pending, and returns a boolean. True if it's valid and false if it's not. Okay, so validate campaign, takes the campaign, returns a campaign validator. Okay, so validate campaign. So first case we look at is the case of collection. So first, only the campaign owner is allowed to collect contributions. So we should have tx transaction signed by campaign owner campaign. Okay. So that makes sure that only the campaign owner can collect. Alright, now next thing. Let's just move that next one. Yeah. The next thing is the funding target must be reached. So the campaign owner can only collect if the funding target has been reached. So we encode that as follows: total input transaction is at least funding target campaign. Okay, so what the transaction is asking for should be at least what the campaign funding target was. Okay. Next criteria is that collection is only allowed between the end date and the collection time. So we encode that by saying in collection range campaign transaction. There's our helper function being put to work in collection range. Okay, and that's it. So if its transaction has been signed by the owner of the campaign, if the what the owner is asking for is at least the funding target, and if so, the input transaction is at least the funding target, and if we're in the it's an appropriate time between time to collect, then it'll be the collect action will be valid. Okay, now the second case, of course, is if there's a refund. So validate campaign contributor refund transaction. So this is a refund. Yep. Now the first thing is that refunds must go to the original contributor. So the way we would do that is we say that all to contributor pending transaction outputs transaction. Okay, so since we need to check all the outputs of the pending transaction, we need to make sure that they go to the original contributor. So what we're going to do is we are going to basically we have to implement this function to contributor. So let's do that here. Let's do that now. To contributor, takes a contributor, I mean, you could think of this basically as it's a list fold, yeah, or this will check that every single transaction output matches is belongs to the contributor. So contributor pending transaction out. Oops. Pending transaction out. Takes a boolean. Okay, so to contributor contributor key. Give it this pattern matching on the contributor value equals case pending transaction out data of data transaction out false, because this case is if the output is locked, by a script, then it does not go to the contributor. Go to the contributor. Okay. And just public key of the case out key. Then we check obviously that the key in the transaction output data, which we've denoted here P prime, is equal to the key of the contributor, which was key. So if the output goes to a public key, obviously it should be the right one. Okay. All right. So with that, then we can come back to here, and we can look at okay, we can look at the next case. So first of all, we checked now that all the transaction outputs, belong basically to this contributor. Then we need to check that we are in the refund range, so of the campaign. So basically that, because you can only have refunds after the collection deadline has passed. You can't do refunds before that. So that we'll check out. That's another helper function we're using. And then finally, the refund claim must be made by the contributor. So the person who's asking for refund must be the person who contributed. It can't be somebody else asking on their behalf, or obviously that could be. So the way we check that is we have transaction tx signed by, and then we do get contributor, and that's it. That's our, oops, I'm so used to just control S. So that's our validate done. So now we just have to effectively compile our script. Now in order to use it for our campaign, let's see what this book says. In order to use validate to create a validated script for a campaign, it is not enough to simply lift the function, because I think that's what we've been doing in the last examples we looked at. We just lifted the function, but we can't do that because it takes an argument. Because it will result in the wrong type, because it takes an argument. Yeah, we're taking a campaign argument. Before we just had something like something like that. But now we've got that. So what we have to do is that the issue here, the Plutus book explains, is that the specific campaign we use will only be known at runtime, whereas compile script works at compile time. So what we do is we use a function called apply script, which allows us to compile a script and then apply it to data. Yes. So let's look at see what that looks like. We've got make validator script. And then campaign. See, validate the script. So you see, this is the campaign that we get at runtime. Validator script. Okay, so what we do make validator script campaign is equal to, and a validator script, so we always wrap it around validator script. And then here's the thing, we compile the script, do compile script, validate, and now what we've got is when we compile validate, we've got the compiled version of a function which takes a campaign and returns a validator. So using the campaign we get at runtime, what we do is we apply our compile script, to the lifted version of the campaign that we receive as an argument. So that ensures that we got the right, we applied the right campaign at runtime. And that's our validator script done. So the only thing left to do is our endpoints, and we'll do that in the next video. Until then, take care.